Today we're just going to review some factoring and put it all together again. So remember all the steps you're supposed to go through. So let's look at number one. First step, anything in common. So is there anything in common in all three of these? Well, yes, there is. What is it? The biggest thing in common is very important to try to get that. You're going to get 3x, leaving you 2x squared plus 5x minus 3. So now we need to factor that. And again, if you multiply, if you're doing this method, you get 6. So we're looking at factors of 6. The signs need to be different to give me 5. So it would be 6 and 1. And which one needs to be positive? The 6 does. So again, we got our 3x, 2x squared, plus 6x, minus 1x, or just minus x, minus 3. If I group the first two, I'm going to have a 2x that I can factor out, leaving me with x plus 3. And group the second two, I'm going to have a negative 1 I can factor out, leaving me with x plus 3. Now they have the x plus 3. Don't forget to bring your 3x along the whole way. So I'm going to factor out the x plus 3, leaving me 2x minus 1. And again, don't stop until you look at these to see if either any of these can factor anymore. They can't, so we would be done. Okay, looking at this, is there anything in common? No. Is it a difference of squares? No. Is it a perfect square trinomial? Possibly, because we do have a perfect square and we have a perfect square. If we double these and multiply these and double them, yes, we get that. So minus goes there, and a squared on the outside is what that would become. Is there anything in common here? Yes, there is. So again, GCF, very first thing you need to think of. So they have a 4 in common, leaving us x squared minus 25y squared. And then go back through, you might say that again. Is there anything else in common? No. Is it a difference of squares? Well, yes, it is. Perfect square. So x goes there. Perfect square, 5y. Don't you lose your variable on the second term. 1 a minus, 1 a plus. And that would be how that one would factor. Is there anything in common, even though it's got 4 terms? You still need to start with that. No. So since it is 4 terms, we're probably going to group them. So again, you can change grouping if you want. I think I'm just going to group them this way. And there's, oops, can't see my plus sign now, but that is a negative that goes with the 9. So here I have an x squared in common, it looks like, leaving me x minus 4. Here I have a 9 in common, but I'm going to make it a negative 9 that I factor out, leaving me with x minus 4. So now I have an x minus 4 in common. I'm going to factor that out, leaving me x squared minus 9. And I hope that you're, again, looking, because yes, x squared minus 9 does factor into x minus 3 times the quantity x plus 3, because it's a difference of squares. So make sure you factor completely. Number 5, is there anything in common? No. Is it a difference of squares? No. Is it a perfect square trinomial? No. So we kind of go to our guess and check, or multiply these two together and look for factors. So we're looking for factors of 36 that differ by 5, and because we are subtracting. So it looks like 9 and 4 would work, and the 9 needs to be negative. So we're going to have 6y squared minus 9y plus 4y minus 6. Again, if you kind of group them the way they are. Here we have a 3y in common, leaving me 2y minus 3. Here we have a 2 in common, leaving me with 2y minus 3. I'm going to kind of write my answer over here, I think, run out of little room. So I get 2y minus 3 times the quantity 3y plus 2. Again, look at these. Make sure we didn't make any mistakes. Nothing in common, no difference of squares, no perfect squares, so we're probably done. Number 6, anything in common? No. Difference of squares? No. Trinomial square? No. Perfect square trinomial? No. So we just kind of multiply these two together. 36. We're looking at factors of 36 that differ by 3. So we just start listing them. 1 and 36. 2 and 18. Nope. 3 and 12. Don't work. 4 and 9. Don't work. 5 and 5 doesn't go in there. 6 and 6. Nope. 7. No. 8. No. And then we start repeating. So none of those worked. So that tells us it is prime. So don't forget that's a possibility after you've tried all situations though. Alright, big long thing we want to solve. So we probably ought to multiply it all out first and then see what we need to do with it. So let's go ahead and use our FOIL method here. We're going to get 6x squared. Outside you're going to get negative 4, inside negative 3, so that'd be negative 7x. Negative times negative would be plus 2. Here we need to be a little careful, remember. I'm going to put my minus here. I'm going to use my either FOIL method or the special product. It's going to be x squared, multiply these two together and double it, plus 8x. 4 squared would be plus 16. And now I'm going to distribute that negative sign. So it's really minus x squared minus 8x minus 16 equals, going to do over here using the FOIL method, 5x squared. Outside I get negative 10, inside I get 1. That'd be negative 9x minus 2. So let's take care of my x squareds first. 6x squared over here minus 1x squared would be 5x squared. I guess simplify first what I'm doing. Negative 7x and minus 8x would be minus 15x. Positive 2 minus 16 would be minus 14. Equals 5x squared minus 9x minus 2. So if I subtract 5x squared from each side, it is no longer a quadratic equation. It is a linear equation. So remember, to solve a linear equation, we don't really need factoring. We just need to get it set, or get variables on one side, numbers on the other, instead of getting it set equal to 0. So that's what I'm going to do. So I'm going to add 9x to each side. And if I do that, I'm going to get negative 6x minus 14 equal negative 2. So now I would need to add 14 to each side to get negative 6x equals positive 12. And then when I divide by negative 6, I get x equal negative 2. So this turned into be just a linear equation instead of quadratic. Now, could you get it set equal to 0 and factor it? You could, but you don't really need to on this one.